3, 2, 1. Welcome back to Bytes of Pi. Today's Kickstarter will cover Lab6g, searching and sorting an integer list. This lab has a lot to cover, and we're going to cover a lot, so please feel free to stop the video and catch up if we go too fast. We're given three classes in this lab. We're given the integer list class 6g, and then we're given the integer list test 6g, and we're given integer list test new 6g. Right now, all you need to do is copy down the code that's below here and create the right Java classes, and then you should be able to run the first test class, just with the test without the new, right off the bat, and it'll kind of show you what this class does. Essentially, it's exercising the integer list 6g class. Essentially, it's wrapping an integer array, and it does some key. It demonstrates searching and sorting, the linear search and a sort that is ascending. So let's just exercise this. First, I'll create a new list of 10 items long, and I'm going to print that out. And printing it out, you can see it's an array of 10 values, and they're all in different orders. 19, 29, 68, 74, 38. They're not exactly in ascending order, right? So they go up, they go down. It's just an array of integers. Let's sort that array ascending, going from the smallest to the largest. I'm going to hit 2, and then I'm going to print it out again. And sure enough, you can see the smallest to the largest. It's now sorted. The array is in the right order. Let's try and find something. Now it's going to do a linear search, which doesn't matter what order it's going to find it in. Let's look for number 44. All right, let's find it. 344. And it found it in location 5. And there it is. Sure enough, the first instance of 44 is there at section 5. And if we tried to find something that doesn't exist, like say 500, let's just find an element, let's say 500, and it tells us not in the list. So that's really, all that stuff is already coded. You don't have to do it. It's already there. It's exercising these pieces. Now, we're going to be doing, this lab is essentially going to have you modifying this list class, these 4 empty methods. We have replace first, replace all, sort decreasing, and binary search. And essentially, this lab is going to have you filling that out. I'm gonna walk through the first one with you. Replace first. Let's take a look at that. So essentially, the method will replace the first occurrence of old val in the list with new val. So the method will take in an old value, whatever that value is, and replace it with new value. So for example, I want to replace 29 with 30. I will put in 29 here and 30 here, and if I was to print it out again, it would show that replaced with 30. Sounds fairly simple. Now let's take a look back. It suggests we already have methods to find the old values. Let's use it. We don't have to create the algorithm to search again. We already have a function called search. So let's start off with that. I want to find the place in the array where that first value occurs. So let's do that. I'll say int I hold equals search old val. That's pretty simple. Okay. If it returns, it'll have a non-negative integer. If it can't find it, it'll be -1. So if it finds it, we'll create an if statement here. If I hold is greater than or equal 0, that means if it found it, we want to do something. Well, let's see if we have another. We have the set value, which will set a value at a particular place in the array. So I will want to call the set value. Now let's take a look at set value. It has an index and the value. So at the position we found it in, I want to set the value. So at the position I found it in, I found it at I hold. I found this value at I hold, the old val. I want to replace it with the new value. And that's it. So again, this is a lot of stuff. It's doing a lot of things, but because I've already done that, I don't have to redo it again. I just call the right functions. Now for the second function, add replace all, we won't be able to use the search function because it only is able to search for the first time it occurs. It won't be able to search for all of it. So we're going to probably have to do some sort of a loop in here, looping around and finding every instance and replacing it. And I'll let you fill in the meat here. We're probably going to have some sort of if statement, or we say if it matches and then swap it out. Okay, but I'll leave that to you to do. Sort decreasing. This is the third method that we'll need to be implementing here, and we already have a sort function selection sort. We're really going to be reusing this. Sort in decreasing order. Use the same algorithm but modify it to sort the other way. So right now this function, this method right here, will sort increasing, means goes from the lowest to the highest. What we want is to go from the highest to the lowest. So let's copy that. So it's really the same algorithm. We're just going to need to modify it slightly. Alright, so let's go through this function and see what it's doing. We're going to loop through the list one time. Alright, we're going from the smallest, going from the first element to the end of the element. That's what you already know. Now I've got a min index. I'm going to say the minimum index is the place I'm looking at. I have a placeholder. Now we can go to the video to kind of watch the selection sort algorithm and how it works. So we're going to loop through it again, starting from that one to the end of the array, and we're going to find, if anytime we find something that is smaller than that first index, we're going to make that the smallest one. So we loop through from that pointer in the array to the end of the array, and we find the index of the smallest value. Once we've got the smallest index, we want to swap it with that current place. So the first time through the loop, we're looking at position 0, and we look through the entire array to find the smallest value. Once we find the smallest value, we swap position 0 with that smallest array. So if the smallest value is in position 5, we'll swap 0 with 5 and then be done. Next time through the loop, min index will be 1. So we know that 0 is now the smallest. We go to the next one, and we're going to set the min index to that value, and we're going to search it from that position all the way to the end to find the next smallest value. Once we find the next smallest value, we'll swap position 1 with that value, and so on until we get to the end of the array. So that's what this is doing right here. We're going to need to do, now we're looking for the smallest. So there's a couple ways you can do this, and I'm going to kind of hint about it, and I'll leave it up to your implementation. The first thing we could do is we could start from the right. We could instead of starting with 0, we could probably start from the end of the array, and we may need to modify this as well. So if you're going to start from the back of the tail end of the array and work your way to the front, you'll need to probably modify these 4 loops. If you like going from the left to the right, you may, instead of saying minimum, you want to maybe look for the maximums. You may want to change these values as well. So that's a couple hints. I won't do it for you. I'll let you take that one on. Lastly, we're going to want to do the binary search descending. Again, we have the algorithm kind of already written out for us here, the binary search A. And I'll copy that for you, and we'll kind of go through it. So this is searching, assuming that the array that we're searching is ascending, going from lowest to the highest. This binary search descending assumes that we're going from the highest down to the lowest. So let's take a look at this. We have 3 different placeholders. Again, look at the video, the other video, to explain how the binary search works. But we have in the video we have 3 different placeholders. We have low, high, and mid. So we say essentially what we're doing here is we're saying we're looking for a key in the array, and we always look at the midpoint of the array, the section of the array we're looking at. So if I haven't found it, if the key doesn't match the midpoint, and the low is still lower than high. Ultimately, we're going to be moving the low and high closer together until they swap. If we keep shrinking low and high, the search area down, we'll get to a point where they both flip values and low will actually be higher than high. Once that happens, we know that we haven't found it, and it'll skip out of the array. So that's what we're doing right here, is we're saying while low is still lower than high, we're good. So the first part of this if statement is if the key that the midpoint is larger than the key, then we know to search the first half of the array to the left of the midpoint. So if I have the midpoint going from left to right, if I have the array going from left to right and I'm here at the midpoint and I know that the value I'm searching for doesn't match it and it's also smaller, then I'm going to move the high from the end of the array down to the middle. So I'm only going to search the first point, and that's the first half of the array. And that's what this is doing right here. We're searching the lower half of the array. If what we're looking for is larger, then we know to search the upper half of the array. So we move the low point up to the middle. So this essentially is shrinking the search area down till we find it. Once we've skipped out of the loop, we'll skip out if we found it or if we didn't find it and the high meets the low. At the end of this function, we say if we found it, we return the index. Otherwise, we return -1 saying we haven't found it. Now again, this is going from low. This is assuming that it's low and high. It's smaller and larger. So we're probably going to want to look at these if statements here and this switching point here. This will tell you whether, because now we're not looking for, it's not going from lowest to highest, it's going from highest to lowest. So we'll need to modify that to make sure that we search the right part of the array. And this kind of gets down to, do you know how this algorithm works? I'll let you fill in the blanks there. Once you're done, I've kind of skipped ahead and done it. There's this other function called integer list test new, and we can run this and it'll quickly tell you whether you've done it right or not. All 4 of these functions. It's a quick test, and I'm going to run it right here. Alright, so let's take a look. So here's the initial array. It has a couple repeating values. Notice the 20s and the 268s are repeating a couple times. It's called replace first. The first function that we talked about, it replaces the first instance of 20 with 200. And notice positions, it found 20 right here at the start, so it replaced it. And notice there's another 20 here that it didn't replace, and that was untouched. So we know that that function works. The next function we call is replace all. So we're replacing all the 268s with 9s. So taking a look at it, we notice all the 268s are replaced with 9s. So we know that works. Sort decreasing is what's called next, and we notice that it starts from the largest one, 200, and works its way down to 2. And then lastly, now that it's sorted in decreasing order, we look for a 20. In the first occurrence of 20, we keep scanning down and we notice it's at position 11. And 395 isn't in the array, and it returns -1. This concludes the Kickstarter for 6G. Thanks for watching.